Our project is a paper analysis on baseball, a Bayesian hierarchical model for evaluating fielding in Major League Baseball by Jensen, Shirley, and Weiner. First, some background. Major League Baseball is largely discrete in its statistics, which makes most aspects of it easy to measure. Furthermore, there's a relatively small number of outcomes for hitting and pitching events, and for these events, it's easy to determine responsibility. Confounding factors exist, but they're either small or averaged out over a season. For example, ballparks have minor differences in their measurements that may change things slightly. Fielding, on the other hand, is not discrete. Players field balls in play across a continuous field, and this continuous space, among other things, makes fielding difficult to evaluate. A ball in play is either successfully fielded, which leads to an out, or it's unsuccessfully fielded, which leads to a hit. The question is, how can you assign blame for an unsuccessful fielding play? There are some plays which can be labeled an error by an official scorer at each game, and these errors allow you to compare players rudimentarily. However, they're also a very subjective measure and reserved for obvious mistakes. There is also no corresponding reward measure.
A more objective measure for assigning responsibility would be looking at players' ranges. But how can you evaluate range? If, for example, a ball sneaks through the left side of the infield, how can you determine whether a faster or better positioned shortstop could have made the play? There are also many confounding factors in attempting to evaluate range, including the speed and trajectory of the ball and the quality and range of adjacent fielders. Additionally, as we mentioned already, the large and continuous playing surface presents a challenge in how to model that surface. Previous approaches to fielding evaluation completely avoid the issue of modeling a continuous surface, choosing to instead discretize the playing field. These include the ultimate zone rating, which divides the field into 64 large zones, and the probabilistic model of range, which divides the field into 18 pie slices. However, there are some weaknesses with models that choose to discretize the field. These models treat every ball hit into a zone equally, while each zone or slice is quite sizable. Together, these features rather significantly limit the extent to which the models can detect differences between fielders.